refractive index of diamond is given as 2.42, and they are saying the absolute refractive index of glass. Refractive index of glass is 1.50 is given. They are saying find the refractive index of diamond with respect to the glass. So refractive index of diamond with respect to glass we have to find, and how will we write this? Refractive index of glass with respect to diamond. So that's how we will write it. So this is given as 2.42. This is given as 1.50. So when you will calculate, you will, and please calculate this by yourself. Just try it. Okay, then. So I am leaving this on you. You will calculate it. Now the second question. This is the refractive index of diamond with respect to glass. This is written like this. I have already discussed. Second question. CBSE 2011. They are saying the refractive index of diamond is 2.42. What is the meaning of this statement? So I have told you this refractive index is given as the absolute refractive index. Absolute refractive index is given to us. So refractive index of diamond is 2.42. So what is the formula of refractive index? If you are calculating refractive index of any medium. Okay, Azaan, good. Very good. Calculating the refractive index of any medium. So you will write speed of light in air or vacuum divided by speed of light in diamond. So I am representing it speed of light in air, and this is I am representing speed of light in diamond, V suffix D. So this is given as 2.42. So VA divided by VD is equal to 2.42. Now from here you can calculate VD by VA. You will get 1 divided by 2.42. 1 divided by 2.42. So VA divided by 2.42. So the meaning of the statement that diamond have the refractive index of the meaning of this statement, the refractive index of diamond is 2.42, is that you will say speed of light in diamond is 1 upon 2.42 times of speed of light in air. So you will write speed of light in diamond. Speed of light in diamond is 1 upon 2.42 times the speed of light in air. In this way you will write. So I have proved that. So the last question is this. CBSE 2012 appeared in CBSE 2012. So just see this question. This question is again very easy question. Now let's see. Azaan, are you getting what I am telling? Okay, very good, Azaan. Fine. Just read the question once by yourself, then I will discuss. Take it easy and just read the question by yourself. They are saying as the velocity of light increases, the refractive index of the medium decreases. We already know that on increasing the refractive index of a medium, the speed of light in that medium decreases. And they are saying light enters from air to water. Light enters from air to water. So light is entering, this is normal, suppose, from air to water. From air to water, and having the refractive index 4/3. Refractive index of water is 4/3 is given. And we already know that refractive index of air, we will take 1. And they are saying find the speed of light in water. Speed of light in water. VW is the speed of light in water. And speed of light in vacuum. Speed of light in vacuum or air is same. Vacuum, speed of light in vacuum is given. 3 into 10 to the power 8 is given. And the speed of light in air also is 3 into 10 to the power 8 meter per second. We have already solved this question in the last class. So you will write the relation between the speed and the refractive index. Refractive index of air divided by refractive index of water is equal to speed of light in water divided by speed of light in air. So this is 1, this is 4 divided by 3, and this we have to find, and this we have given. So from here we can find this. This is become 3/4 into 3 into 10 to the power 8. So the overall answer will be 9/4 into 10 to the power 8, and when you will calculate this, you will get the answer. I am leaving the calculation on you. So Azaan, this type of question you will get in your board examination from the topic refractive index. Okay, I have covered at least all types of questions that can be asked in your examination. Now this topic will be completed. We will start now refraction by lenses. Refraction by lenses. Azaan, are you ready now? Should I start refraction by lenses? And one thing more I want to just you note this down. All the answers here I have written. Just note it down. And see the method that I have used. In this way, you have to solve the question in the exam. Okay, then. Daily, we will solve the questions of previous year question. Daily, we will solve. This is the question of the assignment, and I want that you should write the answers the way I have solved. You can purchase this type of earphones or headphones for the class. Uh, you have Bluetooth headphones, okay? But the mic of that Bluetooth headphone is not okay. Just note this down in your copy. And small n, I am telling again and again, is the refractive index. And there are two types of refractive indexes: absolute and relative refractive index. Relative refractive index means we are measuring the refractive index with respect to some other medium other than the air. Okay. Just note it down. And Azaan, please join the class on time because we have the limited time. We have only 1 hour. In 1 hour, we have to discuss assignment also, and we have to complete our topic also. Should I scroll down, Azaan? Completed this question. Just complete this and do this calculation at your home. At your home means after this class. Okay. Now we will discuss the lenses. Now we will discuss the lenses. So we have discussed the mirrors, plane mirror, concave and convex mirror. Now we will discuss lenses. Okay, good. So write the heading refraction by lenses. Refraction by lenses. So lenses Spherical lenses. We have discussed spherical mirrors. Now we will discuss spherical lenses. Spherical lenses. And spherical lenses are of two types. First, write what is a spherical lens. First, write what is a spherical lens. So, spherical lens or just write lens only first. So, what is lens? If you want to see the lens, then I can show you. This opticals has the lenses. Okay, so lenses are like this. In real life, lenses are like this. Okay, fine. A lens is a piece of transparent glass bounded by two spherical surfaces. So Azaan, now you can see here. You can see here. This is the lens here, and this lens has one surface this and one surface this, and this is bounded by two spherical surface. This is one spherical surface. This is another spherical surface. Okay, and this have the transparent glass also. Transparent glass means we can see through this glass. We can see through this glass. Okay, okay, fine. So now spherical lenses. There are two types of spherical lens. Convex lens. Another is concave lens. Concave lens. Convex lens is like this. And concave lens is like this. Is like this. Nasir. 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 Hello, Nasir. So this is concave lens. This is convex lens. See here, this surface is bulging outward surface. So you will see this surface is convex surface. and this surface is bulging inward, so you will say concave surface. So you will say concave surface. So convex lens looks like this, concave lens looks like this. So convex lens, this is thick at center, but thinner at the edges. See, this is uh, thicker at the center and thinner at the edges. And this one, thin in the middle. This is in middle. This is thick, thin. Thicker at edges. So here this lens is thicker. So this type of shape this lens has. Thin in the middle, thicker at the edges. Now there is principal axis and the optical center of lens. Optical center and principal axis of lens. So suppose you have a lens, this is the lens you have, and this lens have two spherical surfaces. One surface is this, another is this. And the center point of the lens is known as the optical center. Center point of the lens. This point O is the optical center, and this line is principal axis. This line is the principal axis. So write for the optical center first. Optical center is the center point of lens. Center point of lens. That is O. O is the optical center. And principal axis, this is principal axis, P axis. So principal axis this straight line which is perpendicular this surface, which is perpendicular to both the surfaces, is known as the principal axis. So write for the principal axis, the principal axis of a lens, you can write line passing through optical center and perpendicular to both the surfaces. Both the surfaces. So this is principal axis, this is optical center. In mirrors we have pole, in lenses we have optical center. So note it down. Okay, done. Complete this also. This one. And if you want to make the optical center and the principal axis for the concave lens, then you can draw like this. This is a concave lens. And center of this, and this is the principal axis. So optical center. So for concave lens, you can write this. Change the spelling here. Here, change the spelling of principal. Written, Azaan? So next heading is just now copy with me. Write with me. Principal, focus, and focal length of convex mirror. Principal, focus, and focal length of convex mirror. Suppose this is a convex mirror. Not the mirror. Convex lens, sorry. Convex lens. So this is the convex lens, and this line, this is the convex lens, this is the optical center, this line is the principal axis. So for defining the focus, just see, light rays parallel to principal axis, light rays which are parallel to principal axis these are the light rays which are parallel to principal axis, and these all light rays meeting at a point known as the focus, known as the focus. So this point F is called focus or principal focus. And remember that in case of lens, there are two focus. There are two focus, and this distance between this optical center and this focus is known as the focal length. Distance between this optical center and focus means this distance is known as the focal length, and this focal length is represented by small f. And this length is convex, or we will say it converging lens. Because here the light rays are converging. And these are parallel rays. And this line is the principal axis. This O is the optical center. And this F dash is also focus. This F is also focus. This is principal focus. If the light rays are coming from this side, then will meet at this focus. So means the lens have two foci. So note it down. So the focus is a point at which the parallel rays after refraction from the convex mirror meeting. Principal focus is a point at which the parallel rays after refraction, all the rays are meeting. So these are the parallel rays, and after refraction, these rays are meeting at this point. This point is known as focus, and distance between this optical center and this focus is known as the focal length. Done? Okay, Azaan, now you can leave the class, and from the next time, I want that join the class on time.
Good evening, sir.
Good evening, how are you? Hello.
Fine, sir.
Hello, Nafisa, how are you?
I'm fine, sir.